Our objective for today, I can solve and graph compound one variable inequality. Let's read together. 1, 2, 3. I can solve and graph compound one variable inequality. So, continuing with one variable inequalities. We already finished one step, two step, multi-step. Now we're moving on to compound. And you've heard the word before. I'm going to elaborate on it. You don't need a Ferrier model and you don't need steps. We already have them. Yeah, right now when Y gets back. So we know what one variable inequalities are. We know our steps: simplify, isolate, plot, and check. Is that correct?
Yes.
Okay, so this next part I need you to stay focused and pay attention, please, or you're going to miss the part. Here we go. So writing utensils down, please, and eyes to the front. Here it goes. So quick recap. Look up, please. If I was to ask you to solve this, the first thing you would do is subtract 1 from each side. This will end up being -6 less than x, because this cancels right here. To graph that, you create a number line, starting with the dividing point. What's the dividing point? -6. And it's an open point because this one does not have an equal sign. Is that correct?
Yes.
So if we read it, it says -6 is less than x. -6 is less than which numbers? The ones to the right or the ones to the left? Okay, let me repeat that again. -6 is less than which numbers? The ones on the right or the ones on the left?
Right.
On the right. That is correct. -6 is less than all these numbers. All right. From there, if I was to ask you to solve this one, we also subtract 1, we're left with x less than 1. To graph that, here's my number line. 0, the dividing point is 1. It's an open point because it doesn't have the equal sign. And it says x is less than 1. What numbers are less than 1?
Right.
Everything to the left. So there it is, okay? So today, like I said, now that we have this, today we're going to cover something called compound. Now, you've heard that word in language arts. You've heard it in science, is that correct? No? Okay, so in language arts you've heard it before, and it's when you combine stuff, is that correct? In science, when you actually do mixtures, like of different chemicals or whatever that is, it makes a compound. So therefore the word compound means to combine. So look up, please. So look what I'm going to do. Look up. Who noticed, let's see, who noticed that this right side of this inequality is the same as this left side of the inequality? You guys notice that? X plus 1, x plus 1. You guys see that?
Yeah.
So now check this out. What I'm going to do, I'm going to combine this one with this one. Here it goes. See what happened there? Okay, let me go back again. Here it goes.
I'm scared.
Okay, look up. Look up. I'm going to combine this one with this one, and I hope you see that x plus 1 repeats here and here, and they're going to overlap. Watch. This combination here, this is what we call a compound inequality, because now we have 2 inequalities in one. Therefore, I know it's going to start getting funner now. So what I want to do, I want you to write on your paper where instead of the Ferrier model, you're going to write compound equals to combine. And I'm going to go ahead and work this one out completely so you know exactly the process as to how to solve, graph, and write your solution set. So copy the compound inequality, and this is going to be our example Q. All right. Just copy it and writing utensils down, because this is where I lose some of you. So I need you to stay focused. Here we go. Look up to the screen. So just to recap, look up. If I was to cover this, we know how to solve this, yes?
Yes.
I would draw my line down the inequality sign, and then I know what to do from there. But if I was to cover this, do I know what to do from there? Yes, line down here, and I know what to do here. Is that correct?
Yeah.
Well, today we're going to start solving everything at once. Here it goes. To leave x by itself, what do I do here? Subtract 1, subtract 1, subtract 1. This cancels. We're left with negative 6 less than x less than 1. Copy that, please. Pretty cool, right? Be nice. Okay, and if you have your colored pens, get those ready so that we can graph this. I'm going to get a number line going underneath. Here's 0. I have negative 6 over here and positive 1 over here. So check this out. I'm going to graph first the first part of this compound inequality, the solution. Look up. So I'm going to graph this in red. Negative 6 less than x. Therefore, my dividing point is what? Negative 6. So I open point because it doesn't have an equal sign. And here we go again. Question. Negative 6 is less than what numbers? What is it? Everything to the right.
Right.
Negative 6 is smaller than all these numbers, yes? All right. Now I'm going to switch to blue. I'm going to do the second part of the compound inequality. My dividing point is 1, and it's an open point. There it is. And it says x is less than 1. What numbers are less than 1? Everything to the left. All right? Now, check this out. Does everybody see where the graph intersects the other graph?
Yeah.
All right, so I'm going to highlight it in case you don't see it. Here it goes. I'm going to highlight from here to there. Do you guys see it? Okay? This, the highlighted part where both graphs intersect, that's my solution, because that's what it says here. From the x is in between the negative 6 and the 1. These kind of inequalities, although they're called compound inequalities, are also known as and inequalities. Why and? Because the solution is this and that. Both of them are intersecting, that's why it's this and that. So question, look up. If I was to ask you for a solution, tell your neighbor a number that's within the solution set of this compound inequality. Tell your neighbor one number.
Yeah.
All right. Let's see. Melanie, what's one number that's in the solution set? 0. Is that in here? Yes, that is a solution. How about another one? Cesar. 2, let's see. 1. 2 is over here. No, yes, you said 2. Hold on. Is 2 inside this solution set? No, that is not part of the solution. Okay, give me another one. Negative 5. Is that within the solution set? Yes. Now, check this out. Negative 6 and positive 1 are not part of the solution set. Tell your neighbor why. Why are they not part of the solution set?
Because they're outside of it. Because it chose not to be in that crowd.
Savannah. It doesn't have the equal sign. Look up, please, in the inequality symbol. It doesn't have the equal sign to say that it's included. That's why we leave it open like this, because it's not included in the solution set. That is correct. Everybody understand now? So let's write our solution set. Solution set of all x's such that, and then we write whatever we ended up with at the end of here. It's -6 less than x less than 1. And that's how you solve these. You solve, you graph, and you write your solution set. Okay? Are we doing? Yes? Okay, let's do another one. Example 1b. Did everybody copy this? Okay, here we go. Example 1b. Copy this one. 8 less than 3x minus 1 less than or equal to 11. Okay, let's do this one together. Line down the inequality symbol. Line down the other inequality symbol. Who can get us started? Eric. Add 1, add 1, add 1. We're left with 9 less than 3x less than or equal to 12. So far, so good? And then from there at the end, everyone, divide by 3, divide by 3, divide by 3. We end up with 3 less than x less than or equal to 4. Hands if you got that. Only when we divide by a negative or multiply by a negative. Let's graph this. Get your number line. Here's 0, 1, 2, 3, 4, 5. Let me stretch my number line. All right, I'm going to graph the first part in red. So I box this. It's an open point on the dividing point, which is 3, and it says 3 is less than x. 3 is less than what numbers? 3 is less than 1? 3 is less than 4, 5, and everything to the right. Okay? The other one I'm going to graph in green. The second part, dividing point is 4. Does it include the 4?
No.
Yes, because it has the equal sign. So you plot your point, and it's a solid point. And it says x is less than 4. What numbers are less than 4? Everything to the left. And I hope you see the solution set is in between here. So think about it. Think of a number that's part of the solution set and tell your neighbor that number, please.
3.5.
All right, I heard a lot of you say 3.5, 3.4, 3 point something. Did anybody say 4?
I did.
Look at it. Is 4 part of the solution set?
Yes.
Yes, because it's a solid point. How about 3?
No.
No, because it's an open point. Okay? So let's write our solution set. Solution set of x such that 3 less than x less than or equal to 4. Piece of cake? Okay? All right. So you're going to do the next one by yourself, see how you do. Then I'll give you a challenge one and see how you do with that one. Here we go.
Because this wasn't challenging enough.
Be nice. Example 1b. We got -4 less than or equal to 3n plus 5 less than 11. Ready? Go.
-3 is less than n.
Okay. Tanya, what'd you get for your solution set? Solution set. Hold on. Solution set. Hold on. All n's such that -3 is what? Less than or equal to Okay, let me. Solution set of n, all n, such that negative 3 is less than or equal to, we're missing, less than or, n, less than 2. Hands, have you got that? Looks about right. Tony, can you get that binder? It just fell. And the graph. Let's see. We got 0, negative 3, positive 2. And let's see. I'm going to graph this part first. It's a solid point, and it says negative 3 is less than n. Negative 3 is less than which numbers? Everything to the right? Yes. Negative 3 is less than all these numbers, yes? Very good. Then I graph this one. It's an open point. N is less than 2. All numbers less than 2 are that way. So a solution has to come from this section right here. Everybody got it? All right. Hands if you got the whole thing by yourself. Okay. All right, here goes the challenge one. Here we go. Example, Michael Jordan Q. Bam. Here we go. 10 greater than or equal to negative 2, parentheses, 3x minus 1, close parentheses, plus x, plus 8, greater than or equal to negative 20. You guys got this. I know you have it. Ready, go. All right. Marcelo, give me the first step here. What do I write?
You have to distribute.
Distribute. And I get, let's see, 10 greater than or equal to negative 6x plus 2 plus x plus 8 greater than or equal to negative 20. Hands have you got up to right there. Next, we combine like terms. We ended up with negative 5x plus 10. Hands have you got up to right there. Okay, good. From there, minus 10, we end up with 0 greater than or equal to negative 5x greater than or equal to negative 30. Last step, divide by negative 5, divide by negative 5, divide by negative 5. This is 0 less than or equal to x less than or equal to 6. Hands if you remember to flip it. Good. All right. Therefore, my solution set is x, all x's such that 0 is less than or equal to x less than or equal to 6. And the graph, you know how it intersects, right? All right. Pretty good, right? Okay. So now let's go to another type of compound inequality that's going to look a little bit funky, but still we need to go over this one. Here we go. Copy this one, please. Example 2A. It says 8 plus t greater than or equal to 7, or 8 plus t less than 2. I know, right? You have to write or.
Why?
Por favor. See what I did there? Like, or, okay, never mind. All right, look up, please. So let's start with this one right here. Line down the inequality symbol. To get rid of the 8, what do? Subtract 8, subtract 8. So we're left with t greater than or equal to negative 1. Or subtract 8, subtract 8. T is less than negative 6. Let's graph this. We got 0, negative 1, and negative 6. I'm going to start with red. Does it include the point? Yes, because it's got an equal sign. And then it says t is greater than negative 1. What numbers are greater than negative 1? Everything to the right. There it is. When I'm going to green, open point. T is less than negative 6. What number is less than negative 6? Everything to the left, negative 7 and on. What do you guys notice on this one? They don't intersect. That's why these are known as OR, because the solution is these or these. Let me show you the solution set before you leave. Solution set of t such that t is greater than or equal to negative 1, or t is less than negative 6. There is tutoring today. Your home place right here. It's play sheet 6-4. Do that, por favor. Have a good one, everyone. Enjoy your home play. See you guys tomorrow. Bye.